Can we see me, by the way? Can you see the little screen? Can it see me over here?
No.
A little bit.
Here?
Yeah, okay, yeah.
So like here, I have to be here? So wait, here? No? Really?
You can see what you're writing, but not you.
Well,
Okay.
like where's the edge of the screen?
Yeah,
You can write there.
Okay. Okay. So alpha, as you saw, I'm going to turn off the Geiger counter. It's a little irritating, isn't it? For example, if you had uranium-238, it's just like a chemical reaction. It starts as this, and then it shoots out an alpha particle, and it becomes something else. Because if you think about it, whoops, it doesn't become something bigger, it becomes something ever so slightly smaller, whatever, that has a different mass. It turns out it becomes, I think, thorium-234. And we'll see how that is in just a minute, after this alpha particle shoots out. In fact, I'm going to draw a picture of an alpha particle before I tell you about it chemically. It is composed of, and I know it's much bigger than it really is relative to the rest of the atom. Oops. Ah, crap. Sorry. It's 2 protons and 2 neutrons. So this is the bullet that comes out of the gun here. This is the particle. And if you think about it, if it starts out,
Where am I?
black one. If it starts out as uranium-238, it would be 238 here. And if you look at your periodic tables, you can confirm that it would be 92 here, because there's 92 protons, 238 total particles. Okay, and so if it shoots this thing out, let's decide what would be the notation for this thing. It's because you can treat it just like these others that we've done. It has an isotope notation also. Let's start with the mass number. What would the mass number be for something with 2 protons and 2 neutrons? Uno, dos, tres, cuatro, says Seth. Seth is correct. It would be 4, because protons and neutrons both count towards the mass number, so we would write a 4 here. Okay, that's fine. Now, what goes here is normally the atomic number, which is the same as the number of protons. And so, what would I put here? Dos, says Erica. Erica is correct. It would be a 2. That's right. 4 and 2. So, the last thing to think about is, well, what would we call it? And it turns out, you can use the periodic table as a guideline. If it has 2 protons, it must be helium. Helium has 2 protons. And so, that's what we put here. Even though it doesn't seem to make any sense that this thing that comes shooting out of a nucleus would be an element, but it is. And it turns out, and I really don't think this is misinformation, I'm pretty sure I know that this is true, all of the helium on Earth came from this. Because you think, well, it comes out, it doesn't have any electrons, but electrons are everywhere. It just gathers electrons from space around it. So you just throw a couple of electrons around this thing, and it's helium. And it's there it is, 4,2 helium. That is what we call an alpha particle. Sometimes people write it as 4,2 alpha, but 4,2 helium is another way to write it, and that's how we're going to do it, because we need to learn to do these nuclear decay equations, where you start with one thing, and you get a decay, and you end with another thing. So let's look at what we have left. What do we have left? Well, I know I already wrote it up here, but let's deduce it for ourselves. All right. You've got 238 total particles, right? In the nucleus of this uranium atom, between the protons and the neutrons, you got 238. And you take 4 away. 1, 2, 3, 4. You shoot 4 out. Well, this part's easy, right? You just write, it's just 234. And it's true. Does the orange show up on there? Can you see it on there? It's hard to tell, isn't it? Looks like it shows up?
Yeah.
Okay. And if you think about it, it's just like subtraction, you guys. It is subtraction. Look. 238 minus 4 equals 234. Yeah, there you go. 238 protons and neutrons minus 4 protons and neutrons gives you 234 protons and neutrons. Okay, and it's the same thing with the bottom. You start with 92 protons. You take away 2, 1, 2, and you get 90. That's what goes here. 90. Boom. Well, not really boom. There's no explosion. Don't mistake this with an explosion. But 90. And so the last thing to do, just like all these other problems we did, if you go to the periodic table and you look for number 90, you'll find that it's right here. It's called thorium. Named for Thor, god of thunder. Is it god of thunder? Was that what Thor was? God of thunder? Help me out here, folks. Yep. I didn't see the Avengers. I forgot. Okay. Anyway, that is an alpha decay, is what that's called. Decay because it's sort of falling to pieces here. So that's alpha decay.
Is there any reason that thorium would be named after Thor? Is it like...
No, naming elements is this process that sort of everybody has to agree on. When a new element gets discovered, it's not like when you discover a species. If I discover a species, I can name it after whoever I want. I can name it after my mom. Or your mom, sorry. I didn't really just your mom.